Hello, good viewers. You're welcome. Let's see how we are going to solve this beautiful problem here. So we have 3 to the power 4x plus 3 to the power of 2x equals. We have that, right? So how are you going to do this? So now I would like you to stay focused and see what you are going to do. So a lot of manipulations, but what I know is we are going to get to the main, to the root of this problem. So now what we are going to do from here is that I can rewrite this as 3 to the power of this 4x can be written as having x here, then plus I have 3 then to the power of 2x, then equals here I can have this 1 2 2 2 2. So now moving on, I'm going to bring this 2x inside as 3 2 to the power of x, then 2 will go outside. It allows in a law of indices, okay? So to interchange that, so plus 3 2x, right? So which is equals 1 2 2 2 2. So from there we move on. So from here you can see that these inside the parentheses are the same thing. So let y equals 3 to the power of 2x. So let's call this equation star. So now anywhere we see this, we're going to replace it with what? We replace it with y. So we're going to have y squared plus y, then equals. We now have this. Now I'm going to rewrite this at the right hand side by writing it in this form 1 1 1 1. So 1 2 3 4 in expanded form plus 2 2 2 2. So when you add this and this together, you're going to have this. So now we have y squared plus y equals. Now here again I can rewrite this as 1 1 1 1 times 10 to the power, but I can still leave it like this 0 0 0, right, plus 2 times 1 1 1 1, right? So the next thing I'm going to do is I just want to manipulate something out there, right? So what we are going to do is that I want to rewrite this 1 1 1 and this multiplying. So now if you deduct 1 from here, we're still going to have 9 9 9 9 plus 1. So that means when we add this 9 9 9 9, we're going to have 9,999 plus 1. We're going to give us this, then plus we have 2 times this. So now we move on by having, so this 999 I can also write it as 9 times 1111, then plus 1 plus 2 times 1111. Are you following? So the next thing we are going to do here is that from this right hand side, we are trying to simplify this right hand side. So from here, let m equals 1 1 1 1. If m is 1 1 1 1, so from here put anywhere you see 1 1 1 1, then replace with m. So we have m in the bracket n times m plus 1, then plus 2 times m, right? So now from here, don't forget we are having y raised to power 2 plus y. So now here, try to open the bracket. M times m, we have 9m squared, plus m times 1, we have m, plus what? Plus 2m. So now we're going to have 9m squared plus 3m. Then we have y squared plus y. Right, so moving on, we are going to factorize. So now I'm going to factorize 3m outside here. 3m, we're going to have 3m, that is 3 times 3, 9, m times m squared plus 1. Right, so after that, let me take this back to this. That is, whenever I see m again, I'm going to replace by 11, 11, 11. So this is going to be 3 times 1, 1, 1, right, into bracket 3 times 1111, then plus 1. So now from there, 3 times this is going to be 3, 3, 3, 3, right, multiplying 3 times this plus 1. You can see we're going to have 3, 3, 3, 4, right? So therefore we have y squared plus y equals 3, 3, 3, 3 times 3, 3, 3, 4. Are you getting it, please? If you are enjoying this class, consider subscribing if you have not done that before. So now here, another thing I'm going to do here is that I can take this inside by having y squared plus y minus 3, 3, 3, 3, right, times 3, 3, 3, 4, then equals 0. So now what I'm going to do here is that I'm going to rewrite this. You know, here this y is the y squared plus y into bracket 1. We have 1 here. So we are going to write this in this form. That is, 1 is equals 3, 3, 3, 4 minus 3, 3, 3, 3. If we take away 3, 3, 3, 3 from 3, 3, 3, 4, we are going to have 1. So now let's place this one here. We have y squared plus y into bracket 3, 3, 3, 4 minus 3, 3, 3, 3 minus 3, 3, 3, 3 times 3, 3, 3, 4 equals 0. Are you following? So now from there, if I try to open the bracket, we have y squared plus 3, 3, 3, 4y minus 3, 3, 3, 3y minus 3, 3, 3, 3 times 3, 3, 3, 4, then equals 0. Are you following? So now, from there, what are we going to do? So what we are going to do now is that we are going to do factorization. The factorization in the sense that here, if I try to group it like this, you see that here we're going to have y into bracket y plus 3, 3, 3, 4, and here I'm going to be having minus 3, 3, 3, 3, 3, 3 is common, 3, 3, 3, 3 into bracket y, then plus 3, 3, 3, 4, then equals 0. Y plus 3, 3, 4, y plus 3, 0 is common, so let's bring it out. Y plus 3, 3, 3, 4 is common. Then y, if we divide this by this, we're going to be left with y. If you divide this by this, we're going to have minus 3, 3, 3, 3, which everything is equal 0. So now from there, we have this is 0 form equation where we have y plus 3, 3, 3, 4 to be equal 0, and y minus 3, 3, 3, 3 to be equal 0. So now from there, we have y to be equals 3 minus 3, 3, 3, 4, and this place is y 3, 3, 3, 3. I will transpose this to the other side. So we're going to have, now here, we said from the beginning, we said y to be equals 3, 3, 3, 3 to the power of 2x. That's what we said from the beginning. Here, right, is this. So let's recall. So therefore, which is telling us that here y cannot be what? Y will always be greater than or equals to 0, right? But here we are having y to be minus something here, so therefore this will be cancelled out. Then we go with the second one. This one is greater than 0 actually, so therefore is we're going to have 3, 3, 3. We can write it as power 1 equals 3, 3, 3, 3 to the power of 2x. So since the bases are the same, so therefore the exponents are said to be equal. We have 2x divided by this, we divide by 2, this will cancel this, then we have x to be 1 over 2, which is our solution. That's what we are looking for. So now if you're enjoying this class, kindly share this to your colleagues. If you have not subscribed, consider subscribing today. Hit on the bell icon so that you'll be notified anytime we upload a new content. Thank you for watching. Bye bye.